Right, continuation, right? Extended objects, point object. Now we'll check out this part, like what is rectilinear motion. We said it is straight line. Straight line path, what will be straight line path? Like is moving from one place to other only one stiff fixed direction, right? That kind of a straight line path is rectilinear motion. What is position? Path length, that is distance, displacement, speed, velocity, acceleration, uniform, non-uniform. Speeds, velocities, acceleration for these two. Scalar quantities, vector quantities, frame of reference, kinematics. These are the various things what you are going to learn under this chapter. Now, my idea behind writing all these terminologies is to make sure that just recap for a while how many things you know from this. Of course, too many things are also there. I have just given the basic terminologies what are needed to understand this chapter. You can understand this chapter of straight line, motion in a straight line. If you before understanding, you should be well versed with these terminologies or the different things what we use in this chapter are these are the things. So just recall how many things you know. Do you know what motion is? Yes, it is a movement from place to place. Rest, not moving from place to place. Object, anything under study is called as an object. It may be a stone, it may be a bus, it may be a car, it may be a lorry, train, aeroplane, or person, whatever it is, object. The smallest part with respect to entire universe, I'm too small. I am the point object with respect to universe. When you say point object, with respect to what? Point object with respect to what? Now, this cannot be the point object with respect to, both are almost similar in sizes. But this is a point object with respect to the universe. Bus is very big. But bus is also point object with respect to the universe. When you compare with the bigger things, the smallest thing what comes from that is called as point object. Straight line motion. Rectilinear motion is the other name of straight line motion, which is called as one dimensional. What is one dimensional? Again, we introduce some reference system. Physics always learn with respect to standard reference. Why standard references are needed? Without standard references, we cannot justify the universal truth behind that. Now, if I want to make you understand the standard forms, if I go to one shop and take some sugar, or say 1 kg of sugar, that 1 kg is standard everywhere in the universe. Here, if it is 1 kg, that the standard means that should be 1 kg everywhere in the universe. The things what you chase, 1 kg sugar what you take in Indian shop is same as that of 1 kg sugar what I take in my shop. Or even if you go to American, if you say 1 kg, you will get the same quantity anywhere in the universe. That should be the common. That's the common thing. Whatever we say, that is what is being called standard things. Why is standardization needed? Is standardization needed or not? Of course, it is needed. Without standardization, how can you say what is what? If I say 1 liter of milk, it should be liter only, right? And you might be understood in the previous chapter like what is the standard form. I will not discuss much on that. One dimensional. What is meant by one dimensional? For one dimensional thing, we use some kind of frame of reference. To make you understand, we make use of a frame of reference. So far, we deal with the entire physics is based on three-dimensional thing, but we don't go to three-dimensional thing directly at a stage. We go for one-dimensional first. Later we introduce two-dimensional. Later we introduce three-dimensional. To represent this in terms of thing, we actually make use of certain standard notation in the form of coordinate axis. What is called as coordinate axis. Coordinate axis, you might be well versed again in your previous classes in mathematics and all. On one we represent x-axis, and the thing we represent y-axis. Towards right side of this is called as positive x-axis. Towards left is negative positive axis, negative x-axis, and negative y. This is called as standard reference. Two-dimensional. This is two-dimensional coordinate axis. Why two-dimensional? Because there are two coordinates in this. There is third dimensional. Where is the third dimension is going to be? Third dimension is going to be perpendicularly to this. Three dimensions are always three mutually perpendicular coordinate axes, x, y, and z. If x is along here, y is along here, to these three, you are going to get the perpendicular thing. Now you can check out from my hand, these three are perpendicular to each other. X. This is the way how we have the three-dimensional coordinate axis. Now we are not bothered about all the three dimensions. In this context, we are just bothered about the one dimensional. What do you mean by one dimensional? Either only x-axis or only y-axis or only z-axis. Now the point is, if I say an object is moving along positive x-axis, it should start somewhere here and it should move like this. Only x-axis I am bothered about. If I say an object is moving along positive y-axis, it should start here and it should move. In this contest, in this chapter, we are going to deal with the motion of the body only in one dimensional motion. Motion, now the concepts are clear. Motion in a straight line. We are talking about the change in position of a body along only one dimensions, where only x coordinate changes or y coordinate changes. Or it can go along negative x-axis, it can go along negative, but only one direction change we are talking about. Now there may be a question. Now what happens if an object is moving like this? If I say an object is moving, in the same thing, an object is moving. What kind of motion it is? What you need to do is that check out how, different time intervals, how the position is going to change. If a body is moving, is its x value changing? Here x value is different. How to identify the location value of x for this? At any point of location, if you want to find its value, just draw the perpendiculars to that. Now this is x value, x value, x value, x value. And similarly, draw like this, you are going to get y values. Are both the coordinates x and y are changing, or only y, x is changing or y is changing? If you have some kind of thing. Now how this is if a body has got both changes in terms of x and y coordinates, then it should be representing in this way. But are we bothered about this part now? No. But still, if there is a case like what happens if a body is moving like this? What we have to do is that this kind of thing, coordinate axis, what is actually called as frame of reference. This is called as an imaginary frame of reference. Coordinate axis is this imaginary frame of reference point, where when you want to talk about this motion in this way, you can simply assume this coordinate axis to be shifted like this. Now we are talking about a line in which body is going like this. Now what we have to do to make this in one dimension motion, imagine the coordinate axis to be like this. This is positive x-axis, positive y-axis, negative x-axis, negative y. Now what is it I have done actually? I have just assumed that axis what was present here to move like this. This is the way how it was present. It has now moved like this, so that again all four are perpendicular to each other. But still I am not talking about the body is moving. How many coordinates are changing here? Only x coordinate is changing. Therefore this kind of the path, what we call it as, is called as one dimensional motion. No matter in whatever with the way the body is undergoing a change, we should now take that from the starting point of that. Imagine the coordinate axis, that is purely an imaginary coordinate axis. Understanding this imaginary coordinate axis is the one which talks about the point of observation. That is what the meaning of frame of reference. Does it make any difference? Point of observation, or to make you understand what is this frame of reference? If you don't know what is frame of reference, it could be taken like this. If you watch an object moving in front of you, is it same if you sit and watch? That means if you are in rest position and you are watching that one, and you are also moving and that object is also moving. How to understand this one? I am standing in my location. Now I found a car going in the straight path. Now this is what the frame of reference. Frame of reference is my position. With respect to me, how the change in position of the car is observed. That is, frame of reference is at rest position. When I am doing that one, I am talking about frame of reference which is in rest position. Now the same scenario, let me say you are in the car, you are watching me from the moving car. From your point of view, what is the frame of reference now? Frame of reference from your point of view is in now motion. If I am standing and watching a car, I have some fixed frame of reference and the car is in motion. And with respect to the person who is in the car and watching me, frame of reference is in motion, and with respect to me, he observes that me also going back in some direction. Just observe when you are going by cars or buses or bikes, See the things, what you can say that you can find some of the things are going back, right? Trees, maybe like animals, what are the thing you find on the roads, they also start moving. The frames of reference, this is the thing what we call as, nothing can be studied without having the frame of reference. If I say person is moving from where to where, from where to where, that should be said. Now if I ask you a basic question, how much is the distance you travel to come to Basar, Triplet Basar? How much distance, how much is that? It should be calculated from your frame of reference to the destination. Accordingly, the things will keep on moving. That is frame of reference. In order to understand the concepts of the change in position, always there must be a frame of reference. Without having the concept of frame of reference, you cannot specify the way how the object is moving. Frame of reference is purely the imaginary coordinate axis, which is assumed to be present at the point where the object is about to get the change in position. It is of two kinds, either it could be a rest position or it could be, this is purely imaginary. We will imagine. You must imagine some kind of coordinate axis to see in which direction in the change in position is going to take place. That is, having change only in one dimensional, one straight line path refers to the concept of what? One dimensional motion. Now position, what do you mean by position? Where the location, where the object is. Where the object is. Path length is a change of position, total change of position, total distance. The other meaning of this path length is distance. What do you mean by distance now? What do you mean by distance? If you are moving from one place to other place, how much distance you have traveled from to come to Triplet Basar? How much distance you traveled from your place? I have come from Hyderabad, so my distance is 200 kilometers. Or from your location to this place, some kind of distance is going to take place. Accordingly, path length is a total distance, total path traveled between the initial position and the final position. Displacement means the shortest path takes place. I'll just make you understand what it is. I'll just make you understand what it is. I think I can remove this part after the basic introduction to the contents and all. What I'll do now, that is to make you understand this. Imagine the situation. Consider the situation. You are in your homes and you are now traveling to your campus. You are now traveling to campus. I just want to make you understand what the difference between distance and displacement. If you are a good student, what usually you do, you start from your campus and you would be reaching the campus straight away. Now, initial position is here. Initial position means starting position. At what time you started, let us talk about time and place later. And after some time, where is your final position? This is your final position. What is the total path length now? Difference between final position and the initial. Since it's a straight line path, you can straight away take the distance between the difference or the length, how much it is traveled from here to here is called as, in this case, that is what we call it as a distance. That is if you are a good student. If you are some kind of a naughty students, you don't want to go to campus immediately, you want to have some fun or some kind of different things. What will you do? From here, you go to meet your friends. From there, you both of you go to some kind of a canteen or mess. You eat something, you have tea, cup, coffee or whatever the things you want. Again, then you come back to campus. Now, what is the total distance traveled here? Is it the same final position and initial position or the entire thing? Distance is the total path. Let me say this is some x1. From here to here it is x1. Initially you traveled for x1 meters. Or from here to here x2 and from here to here x3. Now what is the total distance traveled now? It is the sum of x1 plus x2 plus x3 is the distance traveled here. Distance is not simply the change of final position minus initial position. Distance is not the change of final position and the initial position. This entire thing what is covered during this track or during this path is called as distance. The total distance is the total path length traveled during two positions. Now what is displacement, now you should understand the difference between, there is a lot of difference. Distance and displacement are not one and the same. Distance and displacement are not one and the same. There is some kind of difference exists. So distance is the total path length covered during the travel. It is called as a distance. Now shortest distance possible between those two locations is called as displacement. Displacement between home and the campus is always fixed. But we will not travel the displacement every time. The shortest distance traveled, the shortest path traveled between the initial position and final position is called as displacement. But distance is what? Distance is not the same thing. It is the total length traveled between two different locations. Hopefully this is a basic important term you should understand. Without knowing this basic part, you cannot go further. What is that? In physics, in this chapter, the two important terminologies what we are going to get is distance and displacement. Distance is the total path length traveled between final position and initial position, and displacement is the shortest distance traveled between. Now it is from here to here, the shortest distance is this one itself. If not shortest distance, how can you travel? You can travel like this. You can travel in different ways. Infinite ways are there. Infinite path lengths can be possible. Infinite distances can be existing between two different locations. Whereas only one shortest distance possible between first initial position and the final position. And that particular thing is called as what? Displacement. Position. Now we usually should understand the difference between, and these two things are the one which are actually giving rise to this kind of a quantity. Now we say this as a physical quantity. These are the things which actually related to the directions. Direction is an important thing which helps in understanding these two things. Whether any kind of a thing has got these are the quantities. Position, distance, displacement, velocity, speed, acceleration. These are all the different physical quantities, physical parameters. Whether these parameters are having specified directions or not are the one which have been named in the form of scalars and vectors. If any physical quantity has got only magnitude without any direction, then that means direction is not important to describe that. If to describe a physical quantity direction is not needed, then it is called as a scalar. If to describe a physical quantity direction is needed, this is the one which do not need direction to specify this. This is the one which needs direction to specify that. Now you check out this one. Out of these two, can you name what is distance and which one is scalar and which one is vector? Can I call this as a vector quantity? What is vector quantity now? Vector quantity is the one which has no direction, also are needed to express that. Whereas scalar, very sorry. Vector quantity is the one which needs direction to describe that, and scalar quantity is the one which do not need any kind of direction. Now, to express this is distance needed? To explain this distance traveled, is that depending on direction or not? It's not depending on direction. It is moving randomly. There is no specified direction associated with it. That is what I mean to tell you. There is no specified. Accordingly, this is scalar or vector. Clearly, this is a scalar. What about this one now? No matter what all the different ways you go, shortest either from home to campus or campus to home, there is only one fixed direction possible. Accordingly, that is what we call it as displacement. Very clear. Maybe there's something I have written wrong. Can just ignore that in a way I have taken a bit wrong. It is very, I'm just repeating that. Scalar is that quantity which do not need direction to specify that. Vector is that quantity which needs direction to specify this one. There is no direction, comes under scalar quantity. Now you should be clear with this. Hopefully just recap whether the things are clear. Rectilinear, straight line path, you need dimension, one dimension. Unidimensional, one dimensional, rectilinear, all are same. Straight line or rectilinear or unidirection or one dimensional, the meaning is object is moving from one position to the other position along the straight line path. This is a scalar quantity, this is a vector quantity. Now let's back to the next important thing. Now important terms what you're getting is, first important term you should know for definitions part, distance. Now can anybody define what is distance? Distance is a total path length traveled in the given time interval. Within the given time interval, how much is the, because why should we say given time interval? Time is a reference point. I may start at 10 o'clock, you may start at 11 o'clock. We are traveling in the same direction, same path, same way, but not at the same time. Accordingly, with respect to times we talk. Then displacement. It is the shortest distance traveled. How to define this one? The shortest distance possible between two positions is called as the displacement. Now let us get back to the third important thing called as speed. Speed is the rate of distance traveled by a body. What do you mean by rate now? Ratios, you know. Ratio. A by B. A ratio B. Ratio. Dividing something one with the other is called as ratio. A by B. Ratio of A to B is what we call it as A by B. We call this as rate if the denominating factor is replaced by time, rate of A. What is the difference between ratio and rate? Ratio means dividing with something else. But if you replace, hopefully you know these two things. This is called as what? Numerator. The thing what is present here is called as denominator. If in a ratio, denominator is always time, then it is called as rate. What is called as rate? Rate means dividing something with time is called as. If you replace that denominating factor by time, then it is called as rate. Now what is the speed? Speed is the rate at which distance is possible. What is that speed? Let me say speed, let us indicate that by means of s. Now let us talk about the mathematical formulas. If distance is denoted by s, now I have taken x1, x2, s, therefore let me call this as an x direction. So what is the total path length now? Sum of all the distances, right? Distance traveled is equals to sum of all the distances. Accordingly, now I am saying speed is defined as the rate at which distance is traveled. That means the ratio of x with the time is called as the speed. Speed is defined as the rate of, what is x? X is distance traveled or change in position with respect to time. Distance traveled. Speed is defined as the distance traveled by time. Speed is defined as what? It is defined as the distance traveled with time. What is the physical meaning of this speed? At what rate our position is changing? Means what? There are two students, say A and B, starting from home, going in the same path. But one is traveling by cycle, one is traveling on foot. There are two students going in the same way, or only one student going in two different modes. One is by the way of walking and other is by the way of what? Cycle. Do both of them, if I say A and B going in different ways, do both of them reach the campus in the same time? Do both of them reach the campus at the same time? I mean to say, if a person walks to in one particular way on foot and one more person does that on cycle, you can take one more person going on by bike, one more by train, one more by car, different things. Now, would all of them reach the campus in the same time? Let me say both of them are starting at 10 a.m. Would all of them reach the campus at the same time? Now let me say the person who is coming by cycle is reaching by 10:15. How much time he has taken to travel this total path length? 15 minutes is taken. If a person takes 15 minutes to reach this one, a person on foot also takes the same time. Does the person who is coming by foot will take the same time, or will it be more or less? Can he come by 5 minutes? Within 5 minutes can he reach? A person who is cycling cannot come in 5 minutes. How can a person moving on foot will reach within 5 minutes? So obviously the person who is moving on foot will take more time. Let me say he is taking 10:30. Now Now we are introducing the time factors to the change of position. Then in this case, who is said to travel with more speed? Whose speed is more now? Whose speed is more? Clearly, the person who travels at the higher time, the person who takes more time should have less speed, because distance speed is inversely proportional to time. If you take more time, lesser speed you are going to get. If you take less time, inversely, right? 1 by inversely. That means the person who is taking 15 minutes will be having more speed with him than the person who is taking 30 minutes less speed. Clearly, if you start from one location, go to other location. What do you mean by speed now? At what rate your position is changing? If your position is changing at a higher speed, if you are traveling at a high speed, then you are going to travel the distance. If you are going to travel at high speed, it means that you should reach that in the less interval of time. The rate at which position of the body is changing is called as a speed. Now another important thing is this speed a scalar or vector? Is this speed a scalar or vector? Since distance traveled is scalar, speed will also comes as what? Scalar only. Speed. Now remember this thing. With respect to one kind of physical parameter, minimum you should know three things. One is the definition of that word. Second is the units in what it is expressed. Hopefully you understood the importance of units. You should always express any physical quantity. No physical quantity can be left alone without any units. Can you say anything without any units? How much you traveled to reach campus? 200. If I say 200, I traveled 200 to come to campus. What does it mean? 200 meters, centimeters, millimeters, micrometers, kilometers. It should be specified. That particular thing is called as unit. You should always specify any kind of a physical quantity by means of a unit. So with respect to any parameter, you should know minimum three things. One is the definition of that. SI units, again units are classified. You have learned earlier, right? Units are classified. SI unit of that for convenience sake. Now it is traveling total of X meters. A physical parameter is complete if it has both magnitude and units. Magnitude 200. Example. Meters unit 200 meters makes sense. Mahesh Babu is 6. Mahesh Babu is 6 what? Centimeters, millimeters, inches. You understand, right? Right. To my house every day I get a milk of 1 liter. It makes sense. Uncle, give me sugar. Which makes sense? Uncle, give me sugar or give me 1 kg of sugar. 1 kg. Uncle, give me 2 sugar. 2 kg of sugar. It should be specified. Physical parameter is incomplete if you have. So definition, unit, as well as the dimensional formula. Sorry, whether it is scalar or vector quantity. Dimensional formulas we'll learn later. I mean, in the previous chapter learned that is scalar vector. Now, distance is a scalar quantity. Distance is expressed in what? In SI system, it is expressed in meters. Now, speed, distance by time. Distance is a scalar. Speed is a scalar quantity. Now, what are units of this one? Units is distance is expressed in terms of meters and time is expressed in terms of seconds. Therefore, speed is definition. Now, I am just recalling the things. Speed is defined as the rate at which the position of the distance traveled with respect to time. It is a scalar quantity. It is expressed in units of what? Meters per second. Now, displacement, the shortest possible distance traveled between two positions, initial and final position, expressed always in terms of meters. Distance can be always made in terms of meters. Now, the ratio of this the rate at which displacement of the body changes. The rate at which distance of the body changes is called as speed. The rate at which displacement of a body changes is called as what? Velocity. Now we can understand the things something like this. Let me just pause a while. I'll just erase the board. Right. Let's get back to this. These are the things what you have learned so far. Distance is a scalar quantity expressed in meters. Total path length traveled with the body. Speed, rate of change of position. Distance is change of position. Dividing with time is rate of change of position. In physical terms, rate of change of position. It's a scalar quantity expressed. Distance is expressed in terms of meters, time is expressed in terms of seconds. Time, the SI unit of time is seconds. You must know all these things. Meters per second. Displacement is a vector quantity expressed in meters. Velocity defined as what? Rate of change of displacement of a body. Physical terms, rate of change of displacement of a body. Displacement is meters, time is seconds, meters per second. Now, before going further, let me tell you, there is a way of understanding physics, understanding and usage of terminologies in the proper way. What is usage of terminologies in a proper way? You should be in a position to get the differences between all the things. As an example, I'll tell you. We use the word called as propagation, transfer, motion, movement, right? All are talking about the same thing, motion of a body, propagation of light, transfer of heat. All these three are doing the same actions, right? All are in motion, but we are using a different context. We will not say motion of heat. Do we say motion of heat if we come across? No. We say propagation of heat or transfer of heat, propagation of light. That is the way physicists should be well versed with the usage of the terminologies in the proper way. Here we are not talking about the propagation of a body, propagation of motion. That depends on you. How much more you acquire, more clarity you'll get on how to apply this one. Now we should usage the physics terminologies in the more appropriate way to understand it thoroughly. If you understand physics and if you cannot put it in the right things, that cannot be called as physics will not do that, right? Accordingly, understand the terminologies. Just check out how are we defining the speed. Speed is defined as the rate of change of position of a body. Speed is defined as rate of divided by time, right? I told you, divided by time. What is position? Distance, change in position of a body. Rate of change of position of a body. No need to say with respect to time because we said rate of. If you don't use rate of, you can say like this. Speed is the change in position of a body with respect to time. I want you people to clearly understand this concept. Get clarity on this. Speed is defined as the rate of change of position of a body. One way. One other way. Speed is defined as the change in position of a body with respect to time. Similarly, velocity is defined as rate of change of displacement of the body. Rate of change of displacement of the body, right? Accordingly, now we'll talk about uniform speed. What is speed? Distance by time. What it should be uniform? Uniform means in the given time interval, how much change takes place in one time, the same should take place. If both are same, in simple words, both are same. What is that? Now we'll introduce some graphs to understand this. Let us talk about the graphical way. Graphical representation, right? Let us understand what this graphical representation is. Graphical representation means showing these things in the form of a graph. Since we are talking about